Okay, so let's look at an example, a very simple example. Okay, so we have a second order linear differential equation and we know the first solution. So we need to shoot for the second solution. Again, I'm going to use the general approach here. If you're using the general approach, you don't have to have your differential equation in standard form. Okay, so we choose our y. We say y is u times y1, which is x. So y2 is actually u times x, but I don't write that subscript 2 just to make our life easy. So y is u times x. Now I'm going to substitute that into the differential equation. But we have to find y primes and y double primes. So y prime means we have to apply product rule here. So what you do in product rule, you differentiate u, which you get u prime, and keep x unchanged. Now the x terms, okay, so you keep u unchanged, differentiate x, that's 1. Now you find y double prime, which you apply the product rule again here, but here you don't need product rule in u. So if you use product rule here, you get u double prime, keep x unchanged. Now you keep u prime unchanged, differentiate x, which is 1. Now you don't use product rule differentiating u because it's just a single function, you get u prime. So we found y prime, y double prime. Let's substitute them into the differential equation. So x square times u double prime x plus u prime. Oh, here this is 2u prime, right? Well, let's make our life easy. So this is 2u double u prime minus x y prime is x u prime plus u plus y is u x equal to 0. Okay, y is u times x. Good, so let's distribute these brackets. Well, x cube u double prime plus 2x square u prime minus x square u prime minus xu plus xu is equal to 0. Now you already know, you can see u terms cancel out. Remember methodology? In the methodology, we got rid of the u term. The u term vanished, right? Here the same will happen. Now what you get is, well, we can write this x cube u double prime. Simplifying these two terms, 2x square minus x square is x square, right? X square u prime equal to 0. Good. So we get a second order simple differential equation of u. Now what did we do in the methodology? We make a change of variable. Same process, right? But when you're doing an example, it's much more simpler. Alright. So we say w is u prime. So instead of u prime, we use w. So we have x square w here, but u double prime means w prime, right? So this is x cube w prime is equal to 0. Alright, so let's take this term to the right hand side. Minus x square w. Let's divide by x cube. So w prime minus w over x, because x square over x cube is 1 over x. Now we get a very simple first order differential equation of w. That is what you always should get in reduction of order method. Okay, good. Now w prime is dw over dx, which is negative w over x. Okay, we can solve this by separation of variables very easily. Take that w to the left and keep negative 1 over x on the right. Now let's integrate both sides. So if you integrate 1 over w, you get natural log w. If you integrate 1 over s, you get negative natural log x because of the negative, plus c1. c1 is an arbitrary constant. So now we need the explicit solution of w. So let's take the e of the other side, e to the negative natural log x plus c1, which can be written as e to the negative natural log x, e to the c1. E to the c1 is actually a constant, another constant, let's call it c2. E to the negative natural log x is, well, we can deal with this negative by taking it to the denominator. I think you have seen these tricks in the integrating factor method, right? Dealing with these logarithmic properties and power properties. E to the natural log x is what? Remember, it is x, right? So w is c2 over x. Okay, so w is c2 over x. Now our goal is to find u. How did we find u? W is u prime, so let's use that. U prime is c2 over x. U prime means du over dx, so let's rewrite in that way. Now if you want to find u, again separation of variables or integrate this with respect to x, right? Because you know the derivative of u prime, now you need to find u. Okay, so if you integrate du c2 of x dx, let's integrate. So if you integrate, you get u here. If you integrate 1 of x, it's natural log x, right? Plus c3. So this is my u. Okay, we are almost done. Now we get to choose our c2 and c3, get to choose our constants here. Okay, so here let me say my c2 to be 1 because I get clean here. Let's get rid of c3 to be 0. So u is just natural log x. Try to get a one function, cleaner function like that. So u is natural log x. All right, so our whole goal was to find u, remember? And then we said y2 is u times first solution, right, which is x. So what is y2? Natural log x times x. This is the second solution. First solution was just x, and these two are two linearly independent solutions. So we can write the general solution for the differential equation: arbitrary constant times first solution plus arbitrary constant times second solution. That is the final general solution. Okay, so the whole method is depend on, okay, find y is u times y1, apply the product rule, find u prime, u double prime and u prime, substitute them into the differential equation, simplify it, get rid of u. You will be able to get rid of u. You will get a cleaner second order differential equation of u. Make a change of variables. W is u prime, rewrite the differential equation as a first order differential equation of w, then solve that first order differential equation. Could be separation of variables, could be integrating factor method. Use the appropriate method and solve the differential equation. Find w. Now once you find w is u prime, so u prime is equal to what you find for w. So to get u out of u prime, you do another integration, then you get u. So you know u, the second solution is u times the first solution. So y1, it's already given to you. Y2 is the u that you found times y1. So you know now y1 and y2. You can write the general solution. Y is equal to c1 times y1 plus c2 times y2. That's the whole procedure. Okay, see you in another example video. Okay, thank you.